we are going to add these two. Now, here is where the first challenges come to. When you are adding here, because we have a power here, don't add using the calculator. That's why we have a lot of space here. Do the working there to convince the teacher that you know what you are doing. 1.6602, we add bar 1. You're going to see the difference of why I'm saying don't use the calculator. Try to use the calculator first and write your answer. The calculator will be 1.6602 plus bar 1, which is negative 1.7482. That is, using the calculator, you are getting negative 0.0880 if you are using the calculator. But let us now work the actual working. 2 minus 2, it is 0. Then here I'll borrow 1 to put there to be 10. There I have 2. Then 5 and 4, I have 1. Then on this part now, we borrow 1 from here to remain 0, so that we put there to be 16. So 16 minus 7, that is 9. Point 0, 0, oh, we were adding, correct? Sorry for that, we were adding. So let us add it using the calculator. 1.6602, it will be minus 1.74482, which is still the same thing. We are getting 0 point if you use the calculator to add. So let us add using the actual way. So if I add it from this point, we'll have 2 plus 2, which is 4. 0, I'll have 8. Then 6 and 4, it is 0, I carry 1 because of 10. 7 plus 7, it is 14, I carry 1. Then it is 1 plus 1, which is 2, minus 1, which is 1. You see the difference? Look at the difference. And if I use the calculator, I am getting negative 0.0880. You see? Why am I putting here? I've indicated here negative because if I have a positive and a negative, which is the power form, it will be a negative. So if you use the calculator using the logarithm, you are going to get wrong. So just add it manually. Normal point. Then now we can proceed. After working out the denominator, we are going to take the numerator and the answer we have gotten in the denominator, because it is over. Over is the same as division. And in indices we say division becomes subtraction. Therefore, we are also going to subtract that using the normal way, not the calculator. So we are going to have 0.4370, 1.4080. We subtract. Here we have 0. You borrow 1 from this part to become 17. I have 17 minus 8, which is 9. Here I have 2, 0, then 0 minus 1, it's bar 1. You know, and now if we do try to solve this one using the calculator, what are you getting? You are getting, using the calculator, if you do, using the calculator, it is negative 0.9714, which is very different to what we are getting here. So kindly avoid using the calculator at this point. Yeah, here it is 4. I'm doing more of explanation with the errors. That's why I get a little bit confused. Let us redo it again. 0.4370, we subtract 1.4084. You borrow 1, it becomes 6. Here we have 6. We borrow 1, it becomes 820.1. We are still getting the contrary answer to the calculator. You see? So we'll have our answer here as bar 1, 0.0286. So if we continue, from this point you're supposed to find the antilog, just doing a reverse of what was happening. You realize that when it was power 0, we started with 0. When it is 1, it is 1 here. When it's negative 1, it is negative 1. Therefore, if this point, it is bar 1, we are supposed to put bar 1. But before you do this, go back to the question and check. This one here, we have a square root, a cube root of 3. Therefore, my answer here should be divisible, divided by 3. You see? Before you do the antilog, go back to the question and solve the cube root function. So if I try to work out the cube root function so that you can see it clearly, that's another point that is very much interesting. We are going to say that because negative 1 cannot be divided by 3, what you are going to do, you are going to look for a multiple of 3. So a multiple of 3 that can be divisible by 3, 1, that is closer to it, it is 3. So if I write bar 3 just here, bar 3, which number will I add to bar 3 to get negative 1? The number, it is 2. So if I have bar 3 plus 2, it is negative 1. So I can use this equation here to replace negative 1. Therefore, I'm going to divide that one by 3. This is now how my new equation is going to be. It will be now bar 3 plus 2, which is representing negative 1, 0.0286. So, negative 3 will divide negative 3 by 1 times. Plus, now I'll have 2.0286 divided by 3, which is 0.6762. Therefore, negative 1 plus 0, I'll be having bar 1.6762. Now, from this point is when I use the antilog method. And before you use antilog method, must indicate with a small arrow to show antilog. Times 10 bar 1, as what I was trying to explain here. If it is 0 here, we started with bar 0, it is 0. Bar 1, it is 1. Power negative 1, it is 1. Negative 1. Therefore, if here it is negative 1, therefore it means that the power was also negative 1. Then you find the antilog from the point. Antilog of point 6762, which is 4.7446. Then, so 4.7446 times 10 negative 1 will be 0.474. I round off 5 decimal, it should be 4 decimal places, it's logarithm. So that is what my answer should be on that question. So the key areas here that they were testing: 1, it is subtraction of logarithm, and another one, it was division of logarithm that has no same powers. We can proceed now to the next question. which is question 7.